Good morning, Team Alabama. We are going to read on page 169. We got cut short on page 169. In the second to the last paragraph, actually, we'll just start at the top of 169. Astronaut Alan Shepard strapped into the capsule just 6 feet in diameter and less than 7 feet high. The launch was successful and the spacecraft soared to an altitude of 116.5 miles above the Earth. The suborbital flight of the capsule Shepard named Freedom 7 lasted only 15 minutes and 22 seconds and covered 303 miles. Freedom 7 was a pale technological achievement compared to the Russian cosmonauts' flight the month before, but its success helped President John F. Kennedy make a promise to the country to complete a goal significantly more ambitious: a manned mission to the moon. I believe that this nation should commit itself to achieving the goal before this decade is out, of landing a man on the moon and returning him safely to Earth, President Kennedy said before a session of Congress 3 weeks after Shepard splashed down. And that's a picture of John F. Kennedy, and we're on page 170. Every NASA employee involved with the space program started to worry. They were already working nights and weekends to prepare for 6 more scheduled Mercury flights. NASA still hadn't completed its first orbital flight, and President Kennedy had promised they were going to send a man to the moon. Was that an impossible dream? It was a terrifying prospect and the most exhilarating thing they had ever heard. Getting to the moon, one of mankind's deepest and most enduring fantasies, had long been the private dream of many at Langley as well. But with only one operational success under its belt and with 6 Mercury missions to go, NASA's road to the moon seemed unimaginably complex. The engineers estimated that the upcoming orbital flight, including the fully manned global tracking network, required a team of 18,000 people. It would take many times more than that to complete a lunar landing. A new mission control. It became clear that NASA was going to have to expand its facilities and workforce if the program was going to reach the goal of putting a man on the moon. And then rumors spread that the Space Task Group was going to be leaving Hampton, Virginia. The Langley employees campaigned to keep mission control at their base, but NASA was considering other sites. In 1960, 9 locations were shortlisted as possibilities, but Virginia was not one of them. Powerful Texans in Congress used their influence, and Houston was chosen as the site. With Project Mercury in full swing and a brand new research center ready to open in Houston, NASA named it the Manned Spacecraft Center. The space program had more work than it could handle. Katherine Johnson had been asked to transfer to Houston with the group, but she and her husband decided to remain in Virginia in order to stay close to their families. Mission Control might have moved to Houston, but Langley was still a beehive of space activity for Katherine Johnson and her colleagues, who were busy laying the groundwork for meeting NASA's greatest challenge, sending a man to the moon and bringing him safely home. Okay, we're ready for chapter 21. Chapter 21 is Out of the Past, the Future. Chapter 21. Find it on your page 173. Sending a man into space was a tall order, but it was the part about returning him safely to Earth that kept Katherine Johnson and the rest of the Langley employees awake at night. There were countless ways that things could go wrong, and they needed to be ready for each one. The rocket had to operate flawlessly. The Atlas rocket was going to be used to take the Mercury capsule into orbit, but it was temperamental. 2 of its 5 previous launches had ended in failure. One rocket had surged into the sky and then exploded mid-air. There seemed to be an infinite number of things that could go wrong with the spacecraft. The space capsule itself was a sophisticated tin can, but one that required elaborate engineering. The vehicle's oxygen and pressurization systems were all that stood between the life-crushing vacuum of space and the person riding inside. If the capsule wasn't strong enough to withstand the intense forces of the launch, it would explode. Every wire, every switch, every gauge, every component had to be tested and retested to make sure that it worked flawlessly. Success depended on engineers' mastery of the laws of physics and mathematics. The spacecraft demanded extreme precision and accuracy. Even a simple error would have catastrophic consequences. There seemed to be an infinite number of ways things could go wrong, and the only one way to get it right. America's astronaut. Nobody understood the risks of space flight better than astronaut John Glenn. The former U.S. Marine Corps test pilot had been chosen as the astronaut for America's first orbital flight. He pushed his body to the physical limit to prepare for a mission, and he worked tirelessly on the simulators and trainers, preparing for every failure scenario the engineers could imagine. He knew that his life depended on his readiness. As a test pilot, Glenn knew that the only way to remove all risk was to cancel the mission. He understood that he was likely to encounter some unforeseen problems, so he did his best to be ready for them. The preparations took longer than expected, and Project Mercury's launch was pushed back from late 1960 to July of 1961, and then to 1962. And this is a picture on your page 175. John Glenn practices escaping from the Mercury capsule in the Black River. Okay, so he did all kinds of things to prepare himself for this because this had never been done before. The Russians didn't slow down, and in August of 1961, they completed a 17-orbit flight, nearly a full day in space. The Soviet success put even more pressure on NASA to get the mission off the ground. In addition to the technical challenges, the launch team had to deal with the weather. Overcast skies at Cape Canaveral, Florida, delayed takeoff on 2 more dates. Finally, the date was set, February 20th, 1962. John Glenn handled the delays with patience and grace. He stayed in top condition and remained focused. Before taking off, he asked the engineers to complete one more check. He asked them to double-check the math that had been done by the electronic computers. Many of the astronauts didn't fully trust the electronic number-crunching machines, or cruncher machines. As former test pilots, they staked their reputations and their lives on maintaining constant and direct control over their planes. A tiny error in judgment on a second of delay could mean disaster. The Mercury mission linked the spacecraft with the electronic computers on the ground. The astronauts worried. What if the computer lost power or seized up during the flight? When the Space Task Group bought more powerful computers and trajectory equations were programmed into the machines so that they could automatically guide and control the rocket and send information about the capsule's positions back to mission control. If the rocket misfired and sent the capsule into an incorrect orbit, the computer would alert the flight controllers who had the power to abort the missions. The capsule would detach from the rocket and land safely in the sea, where the astronaut could be rescued. Once successfully launched, the capsule would push through the atmosphere and settle into orbit. It would separate from the rocket and establish new connections with the ground stations. The spacecraft would send data back to the tracking stations, which would capture the signals with their 64-foot receiving dishes. The Goddard Space Center in Maryland would also send Mission Control in Texas data about the spaceship's position. Hovering over the giant map of the world at Mission Control was a little cutout of the Mercury capsule, suspended on a wire. As data came into Mission Control, the image of the capsule would move across the map. While it was an unsophisticated map by today's standards, at the time it helped the engineers follow the flight's path. The capsule's signal would bounce from one tracking station to another as it moved. The data would allow the controllers to ask, where was the capsule compared to where they had calculated it to be at that given time? Was it too high, too slow, too low, too fast? They would constantly refine their data and make adjustments. This information would be used to determine exactly when the capsule's rockets should fire to bring the spacecraft back to Earth. For the mission to succeed, the hardware, the software, and the human beings had to function properly. A breakdown in any component would be tragic, and it would all unfold on live television. The human computers crunching numbers were something the astronauts understood and trusted. The women mathematicians dominated their mechanical calculators the same way the test pilots dominated their planes. Spaceship flying computers might be the future, but John Glenn didn't have to trust him. He did trust the human computer, Katherine Johnson. Get the girl to check the numbers, Glenn said. If Katherine Johnson said the numbers were good, he was ready to go. The movie did a great job of showing this, guys. If you haven't seen it, it really highlights that really well. We're going to stop there for right now. Have a great rest of your day, Team Alabama. And if you still need your 50 facts, why don't you add that as a fact? Have a great day.